Set up the probability that at least 2 out of 250 randomly chosen people have the same birthday. So before we answer that question, let's go ahead and do a simpler problem with 5 people instead of 250. And then we just transfer the 250 into the formula we come up with for the 5. So let's just try 5 people, and then we'll try the 250. So these are the steps. Describe no one having the same birthday. So this 5 people do not have the same birthday. In other words, this first person has the option of picking any day of the 365 days in a year. But once this person picks a birthday, the next one cannot pick the same one. So the next person, person number 2, has only 364 days to choose the birthday on. But once these 2 pick their birthday, the next person cannot pick the birthday these picked. So the next person only has 363 days to choose the birthday and down the line. The fourth one only has 362 days to choose from, and the fifth person only has 361 days to choose their birthday. So now, in how many ways can 5 people have different birthdays? So these 5 people have different birthdays. Well, you could answer that, count that by using either the permutation formula and key it into the calculator, or permutation is a multiplication principle with no repetition. It sounds complicated, but just keep your eye on the numbers. So this one, a permutation of 365 objects, arranging 5 at a time. That means you're going to get 365 days, and from the 365 days, you're going to assign a different day to each of these 5 people. That's what this means. So it's a permutation is counting how many ways you could arrange objects. So you could do it this way: 365 days, and how many ways can you arrange them such that 5 days, the 5 days for the 5 birthdays are different. Or this also means, gets closer to our first description up here. It's 365 times 364 times 363 times 362 times 361. If you multiply these, it'll give you in how many ways 5 objects can be arranged from 365 objects available with no repetition. So this describes the number you get from here is how many ways 5 birthdays can be picked such that none of the birthdays are the same. Then this one answers a different question. We're going to put the 2 questions and their answers together to answer our original question. This one says the number of ways 5 people can have a birthday. Notice in this one, they're not saying that they can't have the same birthday. They could have the same birthday or have a different birthday. It doesn't matter. One way of saying it is how many birthdays are available for each person. If it doesn't matter if they pick the same birthday. Well, the first person has 365 days to pick one. The second one, 365 days to pick from. And each one of the 5 people have 365 ways to choose their birthday in a year. You multiply, because when you multiply these numbers, this will give you in how many ways you can choose 5 birthdays from the year, from 365 days. Notice it's 365 to the 5th power. So this describes all the possible birthdays, repeated or not repeated. So this is the total number of possible birthdays people can have, 5 people can have. This one is the probability none of the 5 people have the same birthday. So notice, we count in how many people or how many ways you could pick 5 different birthdays. Now we're going to ask, well, what's the probability of that happening? The original description was we were just counting, but right here they're going to ask, what's the probability of that happening? The probability none of the 5 people have the same birthday. So remember, probability is made up of 2 numbers, a numerator and a denominator. It's a ratio. The top number describes what you're looking for. None have the same birthday, and this is the one we just worked a little while ago. That goes on the top. This is how many fit this description. The denominator for a probability is always the total number of outcomes for that given problem. Well, in this case is how many possible birthdays can 5 people pick, regardless of repeating, not repeating. Total birthdays possible. That's this number. So if you were to divide these two, this will answer the question of what's the probability of none of the 5 people having the same birthday. Now let's go to this diagram to understand the next step. If this is our universe of birthdays, the universe always has a probability of 1 in decimal form, 100% in percent form. So the universe always gets a probability of 1 because it has all possible outcomes. Now, part of the universe, this universe we've been talking about in this problem, we have probability of none having the same birthday, and then we have the group of 2 or more people have the same birthday. Together, they make up the universe for this problem. So to find the probability of 2 or more people having the same birthday, all you have to do is say 1 minus the probability of none having the same birthday, and that will give you this part, which would be 2 or more people having the same birthday. So all you have to do is say 1 minus this to answer that question. Therefore, the probability that 2 or more people, at least 2 people, have the same birthday, that was the original question. What's the chances that in a group of 5 people, at least 2 have the same birthday? Well, that would be 1 minus this little portion that we talked about in the previous page. But then we have to answer the original question. They didn't have 5 people, they had 250 people. But now we have a formula for that. Notice where the 5s are. The position of the 5s tells you how many people are involved. For the problem we started off with first, it had 5 people, so you put a 5 here. But for the original question, they were asking about 250, so all you have to do now is put the 250 where the 5 was. And if there's a different number of people, just replace the 250 position for the permutation on the top and for the power in the bottom. So this describes what are the chances that at least 2 people, or if you like 2 or more people, in a group of 250 people will have the same birthday. This would be what you would key into the calculator.